we're going to be doing comparing graphs. Comparing graphs. Okay? So, okay, so here. This little graph here, they call it a box plot. Does anybody have a different name for it? Something else it's been called? It should have been called before. A box and whisker plot. It's normally the same because there's the box and then the whiskers on the end of it. Alright, the things you need to know about a hold on, that's an X, box and whisker. Alright, so a box and whisker plot displays a set of data. You've got this number line down here, and there are key points on the box and whisker plot. 5 key data points. So you're going to be given a set of data points. Like if I listed out everybody's average here, there'll be a list of data points. It's a list of numbers, no matter what it was talking about. But there's 5 key places on that box and whisker plot. This is the median. Anybody know what the median is? The middle number. So the median, and this is just review. The median is the middle number in the data set. Meaning if you put all the data in order from smallest to largest, the median is the middle number. This number is the lowest number, or the low number. This one is the highest number, otherwise known as the max and the min, minimum number, maximum number. The median is also called Q2, which stands for quartile. This point right here is Q1, and this point is Q3. Right, so Q2 is the median, or the middle number of the whole data set. So this line, this number, whatever it is, splits the data into the bottom half and the top half. That part makes sense? So this Q1 is the median of the bottom half, median of the lower half of data, and the Q3 is the median of the upper half of the data. And this shouldn't be the first time you've seen this. It should have come up in 8th grade. Partially come up in 7th grade, but you did it hard in 8th grade. Now there are other things that are not on this that we just need, so I'm going to mention the mean and the mode. You may know what the mean is. Otherwise known as, what do you call it when you add all the numbers up and divide them by the total amount of numbers? The average. This is the average. The mean is the average, and the mode, the number that occurs the most. Number that occurs the most. How about the range? Range is an easy one. Range of numbers that you should be paying attention to everything else. The range is what? High minus the low. Minus low. What about the interquartile range? Might be a new one. You get this? quartile range. That is Q3 minus Q1. That is the length of this box right here. That's inner quartile range. How long that box is. And that's actually the middle set of the data. So you got the lower half of the data, the upper half of the data. That box is the middle set of the data. And a box and whisker plot is divided up. I'm getting a little crowded. Oh, saw another one out here. It's divided up into 4 parts. You've got 25% of the data right here, 25% here, 25% here, and 25% is there. So your data is split up into 4 different parts. So when you hear me say the lower half of the data, there's the lower half, there's the upper half, here's the middle 50% of the data. We can bring that up too. All right, now back to this part. So we got box plots. So I just wanted to go through all that. Now, these things, in this yellow box, from these data, you can interpret the shape of the data, the distribution. So the shape is, are there a lot of low numbers, a lot of high numbers? Is it skewed one way or the other? The distribution, how they're spread out, the spread of the data, and then outliers. I didn't put outliers on there, but there are outliers. So example 1 says, hourly recorded temperature in Fahrenheit every evening at 5 p.m. during the month of May. We created the following box plot for the temperature. So you got your box plot. So there's your lowest number. There's your highest number in May. Your middle number. Then you've got this little dot out here. So here's your outlier. So there was one day in May that the temperature at 5 p.m. was 45. Pretty cold in May at 5 p.m. in the afternoon. So it says, what would happen to the average temperature during the month if the outlier was removed from the data set? Now let me give you a different set of data here, and let's talk about this. Now I'm about to send 2 of you to the office. Let's say here's some test scores. So here's some test scores. Does one of those scores stick out? The 20. The 20 is what they would consider an outlier. It's way far away from the data. There's actually a mathematical calculation you can compute to get the outlier, but you can just tell that 20 is not anywhere near all those other scores. So if I average these numbers, so let's see, 90, 95, y'all have to remember these numbers. So if I average these numbers, 90 plus 90 plus 95 plus 100, what else did I put in there? 85, did I have 2? Yeah. Another 100. Okay, so plus 100. So if I average these, so 1, 2, 3, 4, 5, 6, so divide that by 6, I get an 82, right? 81.67. Now the question says, what happens if we take that outlier out of there and average it again? What do you think is going to happen to the average? If I take that number out, what's going to happen to the average of our data? If I take that 20 out, what's going to happen to that average? Right now, the mean is 81.6 repeating. What do you think the mean is going to do if I take out this 20? If I take out this low number, what should happen to the mean? It should go up, okay? So if I go back over here, and now I take out the 20, I've got 90 plus 95 plus 100 plus 85. Now instead of dividing by 6, I'm going to divide by 5. Now that, whoops, let's see what I did there. Look, I put 9, not 90. 90 plus 95 plus 200 plus 85. There we go. Divided by 5. Okay, there we go. So now the mean is 95. So when we remove that outlier, the outlier and only average those numbers, my mean is now, what was it, 94? 94. So when I take out a low number, what happens to the average? It increases. Well, just the opposite if I had a bunch of low numbers. If I had a bunch of low numbers and all of a sudden I had a high number, if I take out that high number, what do you think is going to happen to the mean? It'll go down. The mean will go down. All right, so back to this problem. What would happen to the average temperature during the month if the outlier was removed from the data set? So this is a low number. So if I take that number out, what's going to happen to the average? It's going to go up, which is what they've got right here. Dealing with an outlier that is less than the rest of the data set, it will cause the mean of the data set to be lower. So if we take it out, it causes it to be higher, which is not any major revelation here. Alright, so dot plot. So in this one it says, on Saturday a pet store randomly surveyed some of its customers who own a dog as to how many days per week, on average, they take their dog on a walk. Right? How many people take their dog on a walk no days? One. How many people take their dog on a walk 2 days? 2 days. 1, 2, 3, 4, 5, right? How many people take their dog on a walk 6 days? Everybody understand that? How many take their dog on a walk 5 days? Nobody took it on 5 days, did they? No. So, this time says, where is there a cluster in the data? So between what days, or on what days, is there a lot of things grouped up? Where's most of the data happening? Between 1 and 3, right? So, easy stuff starting out. Now, let me go through here. Instagram. Let me go back. I mentioned this a minute ago, but let me put this back in here. Come on. You've got, everybody know when I say a bell curve? You ever heard of bell curve? Slade? That's warning number 2. Warning number 3, you're heading to the office, bud. That's what we take the data there. A bell curve means all the numbers are distributed evenly. Half of them are below it, half of them are above it. So this is called a normal distribution. Now the other two are skewed. Skewed means it's lopsided. There's more on one end than there is on another. So this, and it's just the opposite of what you think. These are the lower numbers, these are the higher numbers, correct? Okay, so this is going to be called right or positively skewed. Now what they call these things here, these are called the tail of the data. So wherever the tail is, that's how they name it. It's just the opposite of what you think. This, to me, if most of your data is on one end of it, you would think that would be like less skewed or negatively skewed, and it isn't, wherever the tail of the data is. So if this one's right and positively skewed, this one's going to be left and negatively skewed. So on here, and it says, Kelsey likes to attend aerobic classes at her gym. She wears a heart rate monitor during each aerobics class and calculates the number of calories she burns during each class. So here's the number of classes, here's the number of calories burned. So she records the number of calories she burned per aerobics class for 2 months. So then they ask you, is the data symmetric, same as normal distribution? Is it the same on both sides? Is it symmetric, skewed left, skewed right, or there's not enough information to determine if it's skewed? So based on this drawing here, which one do you think it would look like? It looks like more of the data's over here, right? So skewed left. So it tells you, solution down there. And y'all just said the data was skewed left, which is pretty simple. Everything in here you should have already seen. You should have seen this before. Should have seen this before. Not sure if skewness comes up in 8th grade or not. Anybody ever heard of it before? I don't think it does, but depending on the teacher, it could be. Okay. Oops. I'm going to go to number 2. Okay. Interpreting data. Oops. There we go. Alright, so here's what I was talking about before. And you've already got this in your notes. Box plots can be displayed horizontally or vertically. Same thing, no matter which way they turn them. And you've already got this, your smallest value, your minimum, your Q1, median, Q2, largest value. Just got to be careful when it's going vertical. It's not like they've taken this and put this up high. Remember, the highest point is going to be your largest value, so just don't be discouraged about that. Now, I told you your interquartile range. This is important. This is where you find out, and it says right here, they call it fences. I'm not quite sure why they call it fences, but it says the box plot has imaginary fences known as lower and upper fences, and they help to locate outliers in the data set. So the way you find an outlier, so here's an equation you need to write down. The lower outlier is Q1 minus 1.5 times the IQR. Sorry, let me write this down. So right here, I'm just going to write this a different way. And I'll just use lower fence since they used that before. So the lower fence, so we're finding the low outlier, basically that's an O, not a Q, outlier, is, back to this, we're going to say Q1, whatever that number is, minus 1.5 times the IQR, which is the interquartile range. And same thing on the upper fence, Q3 plus 1.5 times the IQR. And these are really easy numbers. I'm getting messy here. Really easy numbers to figure out. In fact, the calculator is going to do the majority of the work for you. It's going to do just about all the work for you. We'll go back over here. So they've got the lower fence and upper fence. So it says the data set below shows the number of guests that a restaurant served served per day over a 14-day period. All right, here's what we're going to do. Here's where you need a calculator. I'll show you how to put all this stuff in here. As it says, using a box plot, determine whether the following statements are true regarding the data set above. Now, so we're going to put all these numbers in here. You're going to have to help me. 90. Well, first, let's go to the calculator. Let's make sure everything is cleared out. To make sure your Y1, make sure everything's cleared out there. Okay, we're going to go to second stat plot. We're going to go to plot 1. And notice right here. See the box and whisker plot? We're going to do the box and whisker plot. So you're going to first put it on. You're going to go to on and hit enter. And then go down to arrow, and go over to the box and whisker plot and hit enter. Everybody got it? All right, now we've got to put our data points in here. So go to stat, edit, clear out anything that you might have in there. All right, now we're going to put our numbers in here. So our first one, 90, 20, 150. So 90, 20, 150. 98, 91, 79, 120. 98, 91, 79, 120. So we're right here, numbers, 122, 121, 140. 122, 121, 140. And 129, 132, 125. So 129, 132, what's that last one, 125? Everybody got this number then? Okay, now, we're gonna quit out of here. And we're gonna go back to stat. And this time we're going to calculate, just like you do stat count 4 or the quadratic or the exponential. Except this time we're doing one variable stat. So you're just going to hit 1. And the calculator is going to ask you, okay, did you put your numbers in L1? You'll say yes. Don't worry about the frequency list. And we're going to hit calculate. It's going to come up with this stuff right here. Let me show you what you're looking at. X bar is your average. Okay? X bar is your average. So when we put things in the calculator, so to use your calculator, use your calculator. You're going to put your numbers in L1. This is what we did. Stat edit. Stat number 1 edit. And then you're going to calculate your measurement using stat calc number 1 again, which is one variable statistic. And then on there, the key things you need to look at, X bar is your mean. So that's your average. So X bar is your mean. This little, looks like a little O with a little hitch on it there, called the standard deviation. I'm going to put it out here right now. It comes up later on. I'm going to go ahead and show you where it is. The standard deviation. Now see the arrow? Calculator telling you there's more stuff. If you go down, you're going to notice everything you need for this box and lister plot right here. Your minimum X is 20, so your lowest point is 20. Your Q1 is 90. Your median is 110. Q3 is 125. Maximum is 140. So the calculator's done everything for you. So remember how you used to have to add all those numbers up and divide by that number, and then you had to put them all in order and count from both ends to the middle to find your median. Calculator's doing everything for you here, okay? So, let's see. Back to, y'all help me remember these. Minimum is 20, so 20, 90, 110, 125, 140. 20, I've already forgot. 20, 90, 110, I've messed up somewhere, 125 and 140. 125. So here's the minimum, here's Q1, here's Q2, here's Q3, and here's the maximum. So all I did was just write those things down. So let's go look at the graph. Calculator's going to do the graph for you. So if I go to, if I just hit graph, I don't have any idea what my window is. Hello? Hey. Uh-huh. Nope. Yep, one in my class. Yeah, it's one of those things. Yeah, no, he didn't come. Okay, see, yeah, no. Alright, what's wrong with my window? Do I need to fix my window? Cause I'm going from -10 to 10, right? -10 to 10, -10 to 10, well, did any of my numbers even go below 10? What was the lowest number? 20, and the highest number, lowest number was 20, highest number was 140. So I need to fix my window. So if we go to window, and let's just say I leave it at 0, whoops, go back up here, leave this one at 0, and what do you want our maximum to be? Does it matter? Gotta be more than 140. Zach, that's your second warning. So what has it gotta be bigger than? Be bigger than 140, so what do we want to see? 145, okay. What do we want to count by? 10, okay, count by 10. Now, do we care about the Y? Not really, I'm just going to put whatever. I'll put 0, just to see. Whoops. Let's put 0 there. Ah! 10. 0, there we go, let me see if I can get that better. Now can you see your data? We can see them. Everybody get to that? I just went from 0 to 10. Now I know some of you don't have it, because some of you had to take your calculator, so you start putting stuff in. Calculator? You get the graph? Everybody else get the graph. Everybody not get the graph. Alright, so back to that question. I said the math part isn't hard because the calculator does everything for you. So it says which one of these are true? Is the data skewed left or is the data skewed right? Skewed left or skewed right? Remember, where's the tail of the data? On the left. So the data is skewed left, so we know that it's skewed left, so one is correct. It's not skewed right, can't be both. It's not symmetric. It's got to be either left, right, or symmetric. The data set contains an outlier at 20. Well, if I hit trace on here, it's telling me my median, and if I go down, there's Q1, and is that an outlier? Is it connected to the data? Does it say it was an outlier? It doesn't really tell us it was an outlier, does it? So we got to calculate that part just to see. So how did we do that? Remember, it's going to be a low outlier. So right here. So Q1. So what's Q1 in your data? What's Q1? 90. So do 90 minus 1.5. Now the IQR. That's Q3 minus Q1. So Q3 minus Q1. I'm going to write it down here. So I'm going to call it LO, low outlier. So we got Q1 minus 1.5 times the IQR. So Q1 is 90 minus 1.5. Well, IQR is Q3 minus Q1. So 125 minus 90. You're going to put that in your calculator. So 90 minus, so I'm going to put out of this, 90 minus 1.5 parentheses, what was it, 125 minus 90. So anything below 37.5 is an outlier. So it's 20 an outlier. Yeah. So going back here, when it says is 20 an outlier, so they're going to go through and say, all right, you do all of this business, but the calculator does all this for us, which is even better. And then it says it's seen that the given data set contains an outlier of 20 because it's less than the lower fringe value of 37.5. So what they've done, this is everything you would have to do without the calculator doing it for you. So like I said, the math part's not hard because the calculator does everything for you. The only thing you have to do is to know how to do this right here. And this was 37.5. So 20 is an outlier because it's below 37.5. So any number below 37.5 is an outlier. Alright, now. Well, we're just going to look at this one. Look at this data. Determine, using the box plot above, determine the shape of the data. So skewed left, skewed right, or symmetric? Skewed left. Most of the data is down here. So skewed left. Is that an outlier? Most definitely an outlier down here. So we already knew that 1 and 4 were correct. So they just graphed everything for you. Alright, example 2. Now, these are called double plot elliptical bars. It's like a double bar graph. And you've got 2 of them right here beside each other. And on your EOC, they're going to give you things like this and ask you stuff about it. So it says, a research group conducted a study regarding the number of minutes that children watch television daily. So the girls are the pink, boys are the black. Makes sense? The group was specifically interested in the difference between the daily television viewing of boys and the daily television viewing of girls. There's just 2 of them. So, which of the following statements is true about the box plots above? About 50%. Now remember I told you, the box plot's divided into 4 parts, right? 25, 25, 25, 25. So about 50% of the boys, we're looking at this one, watch 30 to 60 minutes of television daily. So right here, 30 to 60. Is that 50%? No, that's actually 25%. Okay, so 1's not true. About 50% of the girls watch 0 to 60 minutes of television. So 0 to 60. Is that 50%? No, that's just 25. So it's divided into 4 parts. The median, remember that's Q2, that line that's in the box. The median daily television viewing for girls is greater than the median daily television viewing for boys. Here's the median for girls. Here's the median for boys. Is it larger? Yes. Okay, so 3 is correct. The interquartile range, so that means which box is bigger. That's Q3 minus Q1. So 150 minus 60 is 90. 90 minus 30 is 60. Or just look at it. Which box is longer? This one is, right? Okay, so the interquartile range of girls' daily television viewing is equal to the interquartile range of boys' daily television viewing. No. And you really didn't have to do any numbers. It's just a matter of knowing that this is 25%, this is 25%, and the interquartile range means which box is longer or smaller, the two. So it's going to tell you, the only one statement for is correct. You knew that already. Alright, you get to, Instagram. Hello? Hey. Okay. Mhm. Okay. Does it matter what day? Just the first 10 days? Okay, alright, September 1. That's what I'll put in. Okay, alright, thanks, Phil. Now, Mommy, when we get through those. Alright, anyway, histograms. This is a bar graph where the bars are connected. So, create a histogram. Well, the calculator will do this for you, but we're just going to look at what they've done here. So you got your number of books, 0 to 1. So your intervals, histogram has intervals. The intervals are down the horizontal x-axis. The numbers are going to be up the top. So I'm not going to read through all this because y'all can read. You can create a histogram. Let's see. Right here. What's the maximum range of the number of children? Maximum range. Range means the high minus the low, right? What's the high? 20. What's the low? 5. So, the maximum range, the number of children, y'all let me, what did I look at? Y'all just let me go right along. 20 to 5 is the number of surveyed adults. It says number of children. What's the maximum range of children? 5 to 0. How many of you would have just put 25? Oh, that's 15 and gone right along. Yeah, you would have. Alright, histograms below. It shows test scores of Class A and B. I'd much rather be in Class B, wouldn't y'all? In Class B. Which of the following is true regarding the ranges of the medians of the data sets above? Remember, median's in the middle number. So there's a lot in this little group right here, right? A whole lot in there. So there's 20 people in this group, 50 to 60. There's only 5 people in this group. What do you think the median is? What do you think that middle number is somewhere in here? Well, how many are in this group? 20. So remember, we're counting backwards. Think about it, if you've got your numbers listed here to here. So if I count in 20 here, I got to count in 20 here, right? So this is 5. That's another 5. So that's 10. There's another 10, so that's 20, right? So my median is 20 right here, and then 20 counts this one, and this one. My median is going to be somewhere between here, right? And what about this one? Same thing. If 20 is on this one, then I count in 5, 5, and 10, so my median is going to be in here. So the median for Class A was between 60 and 70. The median for Class B is going to be between 80 and 90. So the range of the median test scores for Class A is greater than the range of the median test scores for Class B. The range of the median test scores for Class A is less than the range of the median test scores for Class B. Okay? The range is equal. No. So, and they go through and do all this, and it comes out as 2. Alright, standard deviation. We're not going to spend a whole lot of time. Remember, they show you all, this is how you do it by hand. You have to fill in each one of these columns. I'm not going to make you go through all that. Just know on your calculator, when you calculate a set of data, like we did a minute ago, that number right there is the standard deviation. This little symbol right here is the standard deviation. That's really all I need here. When you get to math 2, they're probably, depending on who you have, they'll make you do that by hand. I'm not interested in that at this point. Let's see, we're not going to worry about standard deviation for a sample. Same thing. Alright, dot plot. So we've done Bachman-Webster, we've done histograms on a dot plot. We've looked at a dot plot not that much higher. You can do one horizontal, you can do one vertical. Just be aware of the details. So you got, it shows the number of extracurricular activities that each student in Mr. Smith's class participates. So how many people will do nothing? 2. How many people do 3 things? 4. Each one is a student. Okay? And again, talking about median. Alright, so if I've got 2 here, so 1, 2, 1, 2. 1, 2, 3, 4, 1, 2, 3, 4. So where's my median? It's right in there, okay? The median of the data is greater than the mean of the data. Well, we didn't do mean, but could we have done mean? Could you actually list these out? Could I put, in my calculator, could I write down 2 zeros, 4 ones, what is that, 6 2s, 4 3s, and 2 4s. Could I put all that data in the calculator and find the mean? Yeah, I could. Now, what does this shape look like that we talked about? It looks like a bell curve, right? Okay, something on this bell curve, let's go back right here. on the bell curve right here, this middle point, if I do a line from here down, looking like it's a straight line, that is the mean and the median. On a normal distribution, the mean and the median are exactly the same thing. So back over here, the median of the data is greater than the mean. I just trying to give you the answer. You just said this was a normal distribution, right? It's a bell curve. So is the median greater? Is the median less? Is the median equal to the mean? We know it's this one. The interquartile range of the data is 2. How do we find the interquartile range? Q1 and Q3, Q3 minus Q1. So we could put those numbers in there and find the interquartile range, couldn't we? So we're not, I don't want to waste any time on that. So we did say 3 was correct. It's actually 3 and 4. Alright, dot plot. Show the number of the number of school football games that were attended by a group of freshmen and a group of seniors. So there's the freshmen, there's the seniors. So this is the number of games. So how many freshmen attended 3 games? 1. How many seniors attended 1 game? 1 right here, right? Okay, which of the following are true? The mean of the freshman is greater than the mean of the senior. Well, could we go in here and put 0, 0, 1, 1, 1, 1, 1, 2, 2, 2, 2, 3, 4, 4, and do our one variable stat? Could we go in there and then say 1, 1, or 0, 0, 0, 1, 2, 2, 2, 2, 2, 4, 4, 4, 4, 4, 4. Put all in L1 and do one variable stat. And it would be real simple to find these things, right? To find the mean, talk about the median, talk about the standard deviation, talk about the interquartile range. We could do all that. I don't want to again like I said. We're not going to want to. Okay. So now let's go to some. Here's what we did before. The table below shows the test scores of students and a math course. Ready? This is what homework's going to look like. Table below shows the test scores, students and the math course. Which of the following histogram corresponds to the table above? So the first one you've got 3, second one 4, and 7, and 8, and 4. It's a pretty simple one, isn't it? Just to find the histogram that goes along with it. If I go to that first interval, 50 to 59, that one's at 3. That one's not at 3, or is it? What's different between this one and this one? Look at the scale. This one's counting by 1, this one's counting by 5. Does it even make sense to count by 5? No, this only goes to 8, but it's probably not B. That one's counting by 5, probably not C. Is that one counting by 5? No, so it could be A or D, right? 4. Well, that one's at 4. That one's at 4. 70 to 79 is 7. That one's at 7. That one's at 7. Lord have mercy, they look exactly the same to me. Oh, you know what's different? Look what's different. Look, that one has score and that one has, does it have interval? It doesn't have interval. So which one do you think it is? A or D? A? Okay. So A? Yay! Alright, which data sets could be used to create the box plot below? Well, what's the minimum number? 22. What's the highest number? 35. Does that one have a 22 and a 35? Yeah. Does that one? Yeah. Does that one? Yeah. Does that one? Yeah. So, unfortunately, what are we going to have to do here? We're going to have to put these numbers in here and figure out which one has the same data here. Because we want, first thing, we want a minimum of 22, maximum 35, which we know. These are the important numbers. Q1 is 25, Q2 is 27, Q3 is 30. So which one do you want to start with? Which one do you want to start with? I don't care which one. The last one? Alright, so get your calculator. Put in L1, 29, 26, 22. There's that edit. Clear out your L1. So, not what I said. 29, 26, 22. 29, 26, 22. 35, 25, 30, 27. 35, 25, 30, 27. Go ahead and calculate the numbers. Don't forget to hit enter on that last one. There's that count, one variable. And the numbers we need are at the bottom. So minimum is 22. Q1 25, median 27, Q3 30, max 35. Minimum 22, Q1 25, median 27, Q3 is 30, maximum 35. Is that the one we have? We didn't get that one. Oh, no. Oh, which data set? Sorry. See, I didn't even read the problem the right way. Can I see what it says? We had to do all of them. That's my fault. I didn't read the problem. Whoop. So to me, that's a crappy question, because you had to put in those and get it, put in those and get it, put in those and get it, and put in those. So when you get this problem in your homework, don't be fooled like I always write in. Do all 4 sets of data. Alright, histogram below shows the amount of daily television viewing rounded to the nearest minute of a sample of females and a sample of males. Histogram. Alright, which of the following statements is true regarding the ranges of the medians of the data sets above? So the medians. So remember, there's 40 here, 10 here. So if I got 10, 10, and 20, well 10, 10, and 20 is what? 40. So that means it's right in between them. This is 40 and this is 40. The median's right in between them, right? Okay, so same thing here. This one's at 35. So 5 plus 15 is 20. 20 plus 25, 135 there, right? So my median's in here. You agree? Okay, so the top one, the median's right here. Bottom one's median's in here. Alright, there's not enough information to make conclusions regarding the range of the median amount of daily television viewing. Yes or no? Did we just calculate the median? Okay, so was there enough information? Okay, well, the range of the median amount of viewing for females, this one's females on top, this one's males on bottom, is equal to the range of the median. Right? C says is greater than. And obviously D says females is less than. D? What was this median? It was right in between here. What was this median? It was right in here. Which one's larger, the boys or the girls? The boys. So which one of these is truer? The females is equal, the females is greater, the females is less. Less. Yay. What are we going to do here? Dot plot shows representation between daily high temperatures during the month of May for the 2 different cities. Compare the 2 compare the 2 dot plots and answer the following question. For which city was the mean greater? do you think? Well, how are we even gonna do this? Which city was the median greater, and what was the range? There's 3 parts here. Could we put all these in our calculator and find the mean, median, and range? How would you do that? You would put in 65 twice, 70 3 times, 74 3 times. We're not going to do it right now, but this is what you have to do. 74 3 times, 75 4 times, 76 2 times, 78 2 times. See where I'm going with? To answer all these. Let's just take a guess though. Which one do you think has the highest average? The top one or the bottom one? City 1 or City 2? City 2? Okay. City 2 we'll say. The median, the middle number. Where do you think the middle dot here is versus here? Who's going to answer that? Take a guess. 1 or 2? City 1 or City 2? 2? Alright, now think about this. Are these normally distributed? Are these a bell curve? A bell curve means City 1 and City 2 have the same mean and median. Which one has a higher range? High minus the low. That should be an easy one. High minus low. Good Lord. 90 minus 65. 90 minus 67. Which one has the bigger spread? Which one has more numbers here to here? City 1. But we're just guessing. Alright, this is an easy one. That's a box plot. It can be interpreted that about 50% of the campers are 8 years or younger. Here's 8. 8 or younger. 50%? No, how many? 25. 50% are from 8 to 10. 8 to 10. No. 10 or older. 10 or older. Yes. You say all of them. Okay, it can be 10 to 14. That's 3 to 2, right? That's an easy one. Standard deviation. How would we do that? We would put in 73 one time, 74 2 times, 75, 76, 77 twice, 78 3, so on and so forth. Do your one variable statistics and find the standard deviation that would that symbol right there. A very easy problem. Is it a long problem? Yeah, you're talking in numbers, but it's not a hard problem. Take a guess. What do you think? A, B, C, or D? C? No. B? No. B. Yay! Alright, look at this one. Interquartile range of the data. Okay, here's males, here's females. Interquartile range. That means this number 23 minus this number 17. So 23 minus 17 is, now calculator, 6. 20 minus 12. 8. Please tell me y'all can do that in your head. 20 minus 12. So which one, well, are they equal? Are the boxes the same length? No, definitely. The data for the males has a larger spread. That means the high minus the low. So the high minus the low. 25 minus 12, 13. 24 minus 10, 14. The data for the males has a larger spread. No. The median, 20 for the males, 15 for the females. The median for the males is greater than the median for the females. Yes. 20 to 15. And yes. All of the males did more push-ups in 1 minute than 25% of the females. This is a tricky one. It says every one of these numbers did more than 25% of the females. So are all of these numbers more than 25%? Is this 25%? Are all of these more than that? The question is that, because that equals that, is that considered more than or equal to? What do you think? Make a judgment call. Yes or no? No? Okay. 50% of the males and 50% of the females did between 12 and 20. So 50% of the males between 12 and 20. So here's 12, here's 20. 50%? Yeah, so there's 25, there's 25. Alright. 12 and 20 for females. So here's 12 to 20. Is that 50%? Just keep in mind, try to steer you in the right direction. 25, but don't get caught up in the semantics of it and thinking, oh, well, those two equal each other. All of the males are above 25%. So just remember that. Let's just get. So you start doing the homework. Gratuity, that means tip. You look at tip. Gratuity earned per table on Friday and per table on Saturday. Would you rather work on Friday night or Saturday night to get more tips? More money than tips? What does it look like? Okay, first and simple. Which evening was the rain greater? Dawson? You need to go to Dawson? Okay, then keep your eyes open. What's the range of the Friday tip? What's that number? 32 to 5. 32 minus 5 is 27. 30 minus 5 is 35. So which one was greater? This one was 27. This one was 30. Saturday. The interquartile range, well, we don't know because we haven't done all these numbers in there, but we can take a guess. Saturday, Friday, are they equal? Yes. Friday, okay. Nope. Okay, I'm gonna just guess here. Because I want to be completely there. Okay, now, on your Chromebook. You're gonna go to, so open up your Chromebook. You're gonna go to comparing data. We have a limited command. Not very good. That means we would put on one. Not very good at all. You're doing the comparing data. Now remember, you get 10 questions to begin with. You can always get a better score. But I would not go through there just guessing at it, because if you guess, these averages, or these numbers, these scores is averaged up. So you want to do your best in the very beginning. Jack, we have this conversation about every day, don't we?